Welcome back. My name is Athena from Dreamforge Academy, and I will guide you through this lesson. The deploy went green, 49 files, about 5,200 lines. The honest question wasn't whether the code looked right. It was which safety claims had been run against the address a stranger would type. The answer was none of them. That gap is where MCP servers get hurt. Remember those 30-odd MCP vulnerabilities from early 2026? Almost none were exotic. Tokens accepted from the wrong issuer. Private key material served in public. Each takes under a minute to check if you wrote down that it needs checking. You'll finish this lesson with a dated ledger and a real assistant connected to your live app. A verification ledger is a plain list of claims with a result column. It has one rule: nothing is marked done unless it was run against the live thing, not the code. The problem usually isn't laziness, it's guessing. Halfway through this build, a note said one environment variable was unset in production. That was a reasonable guess, and it was wrong. The platform's own list showed it set correctly 123 days earlier. Remember who is calling. When an assistant hits your server, there's no browser, no confirmation dialog, no human hesitating over a red button. Only the checks you actually ran. The first half needs no account and no browser, so write it as a script that takes an origin and exits non-zero on failure. Hours runs 30 checks. A bare post with no token returns 401, and the challenge names every scope you advertise plus the resource metadata pointer. Wrong verbs return 405. The tool endpoint carries no cross-origin header at all, while both discovery documents are open to everyone. Compare those documents as raw text, byte for byte, and check the resource value is your canonical origin plus the MCP path, with no trailing slash. One slash decides whether a token verifies. Point the script at your live origin, not localhost, and read every line. Confirm the address in the output matches your branded domain character for character. Then spot-check the two claims that quietly break tokens. The challenge header on an unauthenticated call has to carry a scope list. A client handed a bare 401 with an empty body has nowhere to go. And the two protected resource documents must be identical as raw text, because clients fetch one or the other depending on who wrote them. Drift between the two is a bug only some assistants can see. Each of these you have to see for yourself. Send a hand-rolled token whose header says the algorithm is none. A 400 at the parser or a 401 at verification are both correct. A 200 means anyone who can guess a user ID can read that user's data. Check the key set serves a key and no private component. Register a client asking for a scope you don't offer and see it refused. Then the right, mark something complete over a real token, confirm it through a different tool, read it on the page, and undo it. Last, disconnect and repeat the identical call with the same unexpired token. Settle your canonical domain before the first person connects. Tokens are minted for exactly one host, so an assistant pointed at a platform alias will discover, register, show consent, sign in, and then fail on its first tool call. It fails late, and it looks like a broken assistant rather than a choice you made. Attaching a domain and updating your auth URL are one operation, not two. Split them and sign-in fails in a way that reads like a wrong password. Change the domain later and everyone already connected has to reconnect. Finally, follow your own written instructions word for word in a real assistant and fix every stall the same day. Thank you for watching. Keep using the course material as you put these lessons into practice. I look forward to guiding you through another Dreamforge Academy course.